This is David Smith with the Morgan Report. We're here at the Surrey, BC plant for Enviroleach. We're talking to Dwayne Nelson, the CEO, and he's going to give us some off-the-cuff thinking about where things are, where they might be headed, and we're actually going to walk through some of the process of where things start out and where they end up. So Dwayne, take it away.
Okay, thanks David. Without giving away too many secrets, I thought we'd just do a precursor, sort of a walk through some of the different stages of processing. For example, behind me is the first stage, which is the pre-shredding stage. So this is where you would put in the whole cable boxes, modems, circuit boards, and so on. It gets ground in this large shredder down to -2 inch. We then separate the steel using magnetic separation. And then from there it goes into our secondary shredder, which is here. From here we take this down to -1 inch. See some of the material sitting inside of each of the shredder. From this point forward, it goes through eddy current separation, where we separate the aluminum from the remaining material. And then further down here, you can see that we do secondary. First would be the VSI impact mills, vertical shaft impact mills. They fall into 2 supplemental impact mills. We're now grinding the material down to -1/4 inch. We'll go around the other side now and I'll show you it. So primary grinding area, as I said, the material goes over the eddy current. There's further magnetic separation, goes through the bucket elevators into the grinding. So grinding down here takes place down to -1/4 inch, goes through the screen and then goes for further grinding at this end. We then separate the material into a -2 millimeter or 1/8 inch fraction. From that point on, we use a series of density tables to remove the substrate, any remaining substrate, and the pure metal parts. So we start to create a +2 millimeter concentrate. The balance of the material goes through the large electrostatic separator, which then breaks it down into -2 millimeter material, and that separates the concentrate or the metallic fraction from the light or organic fraction. Gives you an idea of what the concentrate looks like. So it's almost a pure metal concentrate. Roughly 50% of the precious metals report to the metal concentrate, and the balance is left in the light fraction. In this area here, which is, you can see we've started development of the wet side. So there's a series of tanks in here. We actually use air transfer systems to transfer the organic fraction, and it goes into a series of tanks where we apply the leaching through our Enviroleach product. It takes about a half an hour. It's a continuous cycle, so we process 15 kilos or about 30 pounds an hour. It goes in there, we extract the gold into solution, and then we electroplate the gold out of solution. The remaining material goes in the other room through a series of filtration. So once we've leached the gold out of that organic fraction, it'll be going into this unit here. This is a very sophisticated vacuum filter press technology that's purchased from BHS. It's a German company. And we can talk a little bit about some of the cost savings that we've done. This piece of equipment is typically 300,000 euros, and it takes about 8 months delivery. We happen to have gotten lucky and found 2 of these and purchased it for a fraction of the cost and got immediate delivery of it. You can see in here the various components that have been delivered, not yet installed. This gives you an idea of the vacuum filter pump that will drive that press. And over here are a series of tanks and mills that also will form part of that, the leaching line as well. So we anticipate we're still on track for approximately mid-May to have this finalized and be able to actually electroplate out or electrowin the gold from the solution by May.
Now the electrowinning will take place in this room as well, is that correct?
Yeah, there's actually a vault in the other room, so we'll actually pump the pregnant solution through a series of pipes into the other room in a large concrete vault. It goes into a series of 8 electrowinning cells. They extract the gold on a continuous basis. and then it gets pumped right back through into the process. So once we've extracted the gold from solution, it's regenerated for reuse back into the other room.
And you've got a lot of raw feed here, it looks like, up on the racks here.
That's light fraction. We've actually already extracted the concentrate from that, so that's waiting to go into the wet process line.
Okay.
Each one of those sacks weighs almost a ton, and it ranges anywhere from 50 to 75 grams of gold per ton.
Now, when you get done with this entire process, after the dry and the wet process, you actually end up with, when all the metal has finally been removed, you end up with an inert product. And what happens to that product when you're done with that?
Once we've extracted the gold from the pregnant solution, we filter it through that filter press that I showed you. That material then gets put into large containers, which are picked up daily, and they're actually used in the production of a number of building materials, including cement and concrete.
And before you came up with that solution, you actually were faced with the possibility of needing to landfill it, right? Which it's a cost that you no longer have to bear because they take it off your hands, and it completely the footprint becomes almost non-existent, really, when you think about it.
Yeah, it's almost a zero environmental footprint. There's no water effluent, there's no off-gassing, there's no materials going to landfills, so it's almost a zero environmental footprint. So we're really proud of that. And some of the OEMs and the large recyclers that we're dealing with, that's a very important part of their circular economy, or their ability to say that they're using a green process to not only build the units but to actually recycle the units. So everything gets put back into reuse. So a zero landfill has been a big part of our goal. If we didn't ship it for the use in concrete and cement, you're right, we would be looking at landfilling it, which is not something we want. So we've also investigated a number of other uses for it, including as plastic and polymer fills as well.
Very good. Is there anything else that you'd like to mention about the process, or where you're headed, or just something that you think would be informative?
There's a lot of moving parts, but the fact that we built all of this in, since I think we started construction in August of last year, and we've got the concentrate plant now running. We're very happy with the way that it's working and the products that we're producing. We have started now on the completion of the wet plant, and by May it will be operational. And again, this plant, there's two purposes really. One is obviously to generate cash flow. We feel that this plant operating at 50% capacity will cover all of the overhead of the entire company, not just this operation. But then secondarily, and equally important, is it becomes a showcase of the technology for a lot of the large recycling companies and OEMs that we're currently talking to. So the future of the company lies in our ability to clearly demonstrate an effective recovery and processing of all of this e-waste.
And then it's a matter of modular construction going forward, doing more of the same, larger plants perhaps, and more throughput and this type of a thing, right?
Yes, absolutely.
Very good.
The nice thing is there's no question as to the scalability. We've proven that with the Jabo facility in Memphis. So now it's all about how can we improve and how can we simplify the process so it's on a continuous basis rather than batch basis, and that's what all of our future partners are looking for.
Very good. And you virtually put together a flow chart here that did not exist before you did this processing, and creating the ability to do things in an environmentally friendly way and a recuperative way that didn't exist either, rather than by doing very toxic type of recovery from what the small amount that was being taken back, right?
That's right. I mean, that's what was so difficult, is there's no instruction book. There's no manual that we could follow because it's never been done before. Mm-hmm. So obviously, you make your best guess at this is how it should work, and then you're constantly modifying. And it's taken some time, but clearly I think we've done a tremendous job. The people that we have are all brilliant, hardworking people, and I really think we've accomplished a lot just in the last 6 months alone. So the wet side is a little bit easier because I don't think we have to experiment as much. But clearly the ability to shred and grind the boards to create those two fractions was one of the most difficult portions. The chemistry is clearly is improving on a monthly basis. We're very happy now with the results that we're getting. So we're very confident that we can hit that 15 kilo or 30 pound per hour goal that we set for ourselves. And again, that works out to about 10 tons a day, and which is about 3,000 tons a year, which is a significant amount of materials. And that's only running on a single shift. That'd be a one shift per day.
Wow.
So some of the people we're talking to, clearly they want significantly higher production than that. But really, this is all they have to do is come out and see this plant running, look at the electroplating of the gold, and the results will speak for themselves.
Just a real quick note, recently you mentioned that you're now able to recover palladium from catalytic converters. And
Yes.
Could you tell us just a little thumbnail sketch of how that's looking for you and how you came about down in that?
Well, we were contacted by a catalytic converter recycler in the States. And we know we've been attempting at recovering PGMs using our solution before. So we made some modifications at the laboratory and added some modifiers, did some temperature adjustments, and before we knew it, we were getting 97% recovery on the palladium. And so that opens up another market for us. The catalytic converter market worldwide is approximately $180 billion a year going into it, and the ability to recycle that material from those catalytic converters is of paramount importance to the entire sector. But for us, there's a lot of palladium in e-waste as well. So now we can add that to our list of recoverables from the e-waste.
Tremendous. Well, Dwayne, thank you very much. Really appreciate your time here today, and it's very exciting. And I think this is a story that's going to keep on telling itself and getting larger and larger, and it has the potential to redefine a couple of industries that in a massive way.
It does, and I got to all of the guys in the Morgan Report, we do appreciate their patience. It's been a long haul, but it's going to be well worth it.
Thank you very much, Dwayne. We support you fully, and we're very excited about this. And so thank you again. And this has been David Smith for the Morgan Report, speaking with Dwayne Nelson, CEO of Enviroleach, here at the Surrey, BC plant. Thank you, Dwayne.
Thanks, David.